Right, in this section, 10.2, we're going to talk about rational exponents. What that means is if we have an exponent, that's a fraction. Now, if you recall, we've talked about exponents in the past, but all the exponents we've done have been whole numbers. For example, if we have 4 squared, we know that 4 squared means 4 times 4. That base multiplied however many times the exponent is. Or we could say 16. Or if I have negative 2 cubed, negative 2 cubed means I have negative 2 times negative 2 times negative 2. Negative 2 multiplied 3 times. Or I could say negative 8. We've also talked about radicals, right? Square roots, cube roots, stuff like that. We've talked about that the square root of 4 means what number multiplied by itself gives me the number 4. We could say that the square root of 4 is 2. Or if I asked you for the cube root of negative 8, what number multiplied by itself 3 times gives me negative 8? I get negative 2, because negative 2 times negative 2 times negative 2 gives me negative 8, right? And so we can kind of go back and forth with squares and square roots and cubes and cube roots. But what happens if we have 4 to the 1/2 power? I can't take 4 and multiply it a half a number of times, or that would be kind of weird, right? So what does that really mean? Well, we need to figure out what it equals. So if I'm looking over here and I want to figure out what this equals, maybe I can get rid of the 1/2 exponent by raising it to the second power. But remember, if I have an equation, I have to do the same thing both to the left side and the right side to keep my equation balanced. If I take 4 to the 1/2 and I square it, we've talked about exponents before, and remember when we raise to a power we multiply, I would end up getting just 4 on that side, right? The exponents would reduce. So that means I need to figure out what squared is the same thing as 4. Or could I take the square root of 4 and say 2 squared is the same thing as 4? So then I know that 4 to the 1/2 is the same thing as 2. Which then also means that 4 to the 1/2 is really the same thing as the square root of 4, 2, right? And so raising something to the 1/2 power is really like taking its square root. What we're really doing is we're looking at this bottom number. That's our index, a 2. The top number is really our exponent, our 1. We know when there is no number there, though, we assume that it's a 2. And there is no exponent, we assume that it's a 1. So 4 to the 1/2 is the same thing as the square root of 4, which is just 2. Look at 9 to the 1/2 power. Again, if I want to figure out what 9 to the 1/2 power is, I should be able to square both sides, and then I have 9 equals what squared? Well, what squared gives me 9? AKA, another word for that is, what's the square root of 9? Well, I could say 3, right? So I know that 9 to the 1/2 power is the same thing as the square root of 9, which is 3. So what happens if I have 8 to the 1/3 power now? Well, just like if 4 to the 1/2 is the square root of 4, then 8 to the 1/3 is really the cube root of 8. And so what number multiplied 3 times gives me 8? Well, I can say that 8 to the 1/3 power is 2. So anytime we have a fractional exponent, a to the 1 over nth power, I can really convert it into a radical, where the top number is my exponent and my bottom number, my denominator, is my index. So the nth root of a. Let's practice a few. Look at example number 1. It asks us to write an equivalent expression using radical notation and, if possible, simplify. So instead of saying 16 to the 1/2 power, let's go ahead and convert that into radical notation and see if that allows us to simplify. So we just learned that 16 to the 1/2 power is really the same thing as the square root of 16. Is there a square root of 16? A whole number multiplied by itself that gives me 16? Yeah, I end up getting 4. So I can say that 16 to the 1/2 power is equal to 4. Okay, what about negative 8 to the 1/3 power? We can convert that into radical notation and really say that I have the cube root of negative 8. You notice that my negative 8 has parentheses, so I'm going to make sure that the whole thing goes underneath that cube root. And what number multiplied 3 times by itself gives me negative 8? Well, I can say that negative 8 to the 1/3 power is the same thing as negative 2. All right, on C, I'm going to go ahead and put parentheses. I know it probably wasn't on there. It's probably a typo on my part, but I want to go ahead and put parentheses around the A, the B, and the C because I want the whole thing to be raised to the 1/5 power. If I want to convert that into radical notation, that means the A, the B, and the C are all underneath what kind of root? Yeah, the fifth root, right? So I have the fifth root of A, B, C. I only have one A, I only have one B, I only have one C, so I can't really take the fifth root and simplify it anymore. So that would just be my final answer in radical notation. On D, I have 25x to the 16th, and all of that is raised to the 1/2 power. Let's convert it to radical notation. So 1/2 power is really the same thing as the square root of 25x to the 16th. Let's see if we can reduce or simplify this. I know that the square root of 25 is 5, and I can say, what times what gives me x to the 16th? I could say x to the 8th. Now remember, if this was an even root, I need to be worried about absolute values, especially if I have variables in my um, radicand. But if my answer is also even, then I shouldn't have to worry about absolute values because then everything will turn out to be equal. The left side should equal the right side. So on this one, I don't need absolute values, but I need to be thinking about it, right? All right, let's do one more example in this video, and let's actually go backwards. If I give you a problem in radical notation, would you be able to go backwards and convert it into exponential notation? So look at example number 2a. It says the fifth root of 7ab. If I want to convert it back to exponential notation, you notice that inside my radicand really has an invisible 1 exponent to all of the quantity 7ab. It has a fifth root, so I should be able to convert it back into a fractional exponent and say that this is really 7ab to the 1/5 power. I know it's kind of silly, but I use the saying top dog goes in the house because I know that this top number needs to be the one that's in the house or underneath the radical. So if that helps you, use it. I know it's kind of silly, but any little trick that helps me remember where those numbers go is helpful. So top dog goes in the house. I would say that 7ab in parentheses raised to the 1/5 power. Now those parentheses are important because if you don't have the parentheses, then the only thing that's really underneath or raised to the 1/5 power is the b. And that's not what this says. This says that I want the 7 and the a and the b all to be to the 1/5 power or underneath the fifth root. Okay, look at b. B says that I have an x to the third y over 4. It's really raised to the first power, right? If top dog goes in the house, then I should be able to go backwards, convert it to exponential notation, and say that I have an x cubed y over 4 all to the 1/7 power. All right, C says that I have 5x. That whole thing is raised to the invisible 1 power. Ooh, what's the index on this root if there is no number there? Remember, it's a 2, right? And so top dog goes in the house. I can convert it to exponential notation. Again, using parentheses, I can say that I really have the quantity 5x all raised to the 1/2 power. All right, make sure you can go from exponential notation to radical notation, and then from radical notation into exponential notation. We're going to be using both of those forms to go back and forth and rewrite and possibly simplify more problems here in a little bit.